Hello everybody. So in this tutorial we are going to learn about the FAUST hull classification. So first of all, let's talk about a little about the name FAUST. So it stands for fast, accurate, unsupervised, supervised tree mining. The later part is hull classification. Classification means just to classify the data into certain classes, and the hull means the process of classification in which for a particular kind of classes we will be creating hulls around those classes, and any any point which lies into that hull belongs to that class. This is the idea. You can see here down here the coordinate system. So right now we are taking here two-dimensional coordinate system. I am assuming here that the horizontal line is the x-axis and the vertical line is the y-axis. The idea of choosing this coordinate system in order to explain this FAUST hull classification will be very shortly clear to everybody. So just hold to it. I also want to describe uh, describe briefly here that what we are doing with these points here. So basically these are 8 points we have taken in order to explain this algorithm. So this one is point A, B, C, D, and similarly these are E, F, G, H points. So as you can see that there are two coordinates here, so this represents two-dimensional space. So but this is not the general scenario while we are dealing with the data mining issues. So nowadays, as we know, that there the classification and clustering approaches, they are continuously being applied to many big data applications. So data application, they have millions or trillions of records or dimensions. So in order to represent those will be, let's say if there are 100,000 dimension, that we would have to take a coordinate system in which there will be 100,000 dimension of that. For example, if that dimension is present only along x-axis, then that dimension will be represented by one point which will be non-zero at the beginning, and all other will be zero. For example, if we are taking the example of 100,000 dimension, and if there is only one point lying on the x-axis, then that will be just one value here on x-axis, while the rest are all 9,999 zeros. So just take an idea that how these will be represented. So I'm coming back to this example here, that I have got two-dimensional space here. So this is x-axis along this horizontal line, this is y-axis vertical line. So this point A, it has the value 1 3. So if I project this point 1 on x-axis, so this will be point somewhere here, and similarly 3 to here. So similarly we can project all other points like B, C, D, E, F, G, all to the similarly x as well as y. One thing I also want to mention here, that these these points, they have been categorized into two kinds of color. This one is purple color, this one is green color. So right now I will not go into detail that why this purple color is there here and why this green color is here. So my assumption here is actually not my assumption, actually these are two classes. One is the purple class and another one is a green class, which we have successfully found by applying this FAUST hull classification. We will be very shortly clear with this how these classes have been formed. So in order to give this idea more clearly, Dr. Perrizo, he has already colored these classes into purple and green, and I'm just walking you through all the slides. Uh, if we are going to implement the FAUST Hull classification, we also need to have one unit vector. Unit vector is nothing but a vector which will be chosen by us depending upon what kind of dimension, not dimension, what kind of data we are having. So here you can see that this d1 is a unit vector. So the coordinates of this d1 is 1 and minus 1 by 2. So similarly, 1 something here along x-axis, minus 1 by 2 here. So if I draw a line, so this will be here. I am extending that line along, as you can see, in this direction as well as to this direction. Why am I extending this line? The idea will be clear here. The idea for FAUST Hull classification is that we are calculating the dot product d1 with respect to all the data points which are laying in our two-dimensional coordinate system. So what we are doing, we are projecting this A onto this line here on this unit vector. Similarly, we are trying to project this B here, similarly D, similarly C, and all other. And then based upon this gap, we will be able to figure it out that which points lies to which side. And for example here you can see the last point B, it lies here on the line unit vector, and the green point lies here. So there is a gap between these two classes, and this is a fundamental this is a fundamental basis for our algorithm to distinguish between various classes. So this is the reason that all the classes from this point onwards toward this line are colored purple, and all the classes from this point onward down here on this line are colored green. So as there are only two classes, so all the any data which is somewhere here that will be colored green means we have successfully classified that into a green class, and any data which will be projected on this unit vector here, that will be classified onto a purple class. So this is just a very basic uh, idea of this algorithm. Now our purpose here is to classify the data vertically. So how that is done vertically, so this idea will be cleared very shortly.